So we're going to talk about graphing systems of equations. Now, let's talk a little bit about what a system is. A system is two or more equations that hopefully have something in common, and that something is usually a point. So in other words, it's where, if you were to graph those two equations, it's where they would intersect. So let's take a look at this first system we have here. You notice it has a little curly bracket off to the side, a little set notation. That's not necessary, but we write it a lot just to indicate that it's a set. So let's take the first one, y minus 3x equals negative 4, and let's put that in slope-intercept form. So I'm going to add 3x to the other side. And there you go. It's set. It's in slope-intercept form. So where my 3 is my slope and negative 4 is my y-intercept. So let's go down 1, 2, 3, 4. Put my y-intercept and then go up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. And then do my best attempt at drawing a straight line. Okay. So let's then take the other one. Y plus 2x equals 6. Put that in slope-intercept form, so I'm going to subtract my 2x. So my y-intercept is 6, so 1, 2, 3, 4, 5, 6, way up here. And then go down 2 to the right 1, down 2 to the right 1, and draw my line. And so my solution to this system is where they intersect. It's the point that they have in common. And in this case, it would be 2, 2. And there you go. So that's easy enough. So let's move on. Let's try another one. So this one, the top one's already in slope-intercept form. That's nice. So let's try and graph that. So up 2. And so let's go up 1, 2, 3, 4. Well, we run out of room. So instead I'm going to go down 1, 2, 3, 4, 5, and to the left 1. Okay, and I'm going to draw my line. The bottom one looks like negative 10x plus 2y equals 8. So I'm going to add 10x to the other side. And then let's divide everything up by 2. So I get y equals 5x plus 4. So up 5. Now again, I can't go up, or probably up 4 is what I meant to say. I can't go up 5, so instead I'm going to go down 5 to the right 1. Down 5 to the right 1. And I guess this is where a straight edge would have come in handy. So I apologize that this is not the greatest. And so what the attempt right there is to show that these actually don't cross at all. And so what does that mean? That means they're parallel lines. And then that should make sense because as you look at the equations, you'll see that they have the same slope as one another. And if two lines are parallel, that means they don't cross, so therefore they don't have anything in common. So therefore there would be no solution to this one. So there's no point that either one of these have in common. Okay, let's try one more. What if I start out with this system? Okay, so neither one is really nice for us, so let's start with the top one. So 7x plus 3y equals 9. I'm going to subtract 7x and then divide by 3. Alright, so let's see. Y-intercept's up here at 3, and then I'm going to have to go down 7. 1, 2, 3, 4, 5, 6, 7, and then to the right 3. 1, 2, 3. Alright, let's see if this attempt is better than my last one. Not too bad right there. And let's go to the other equation. So 14x equals negative 6y plus 18. So I'm actually going to subtract 18 to the left. And then let's divide by negative 6. So y equals 14 over negative 6 is going to be negative, and then if I reduce it, it becomes 7/3. And then negative 18 divided by 6 is 3. Okay, and this time, if you notice, it's exactly the same equation. So it's actually lying right on top of it. It's the exact same one. So what does that mean? Well, maybe back in Algebra 1 you would have learned that that would mean there's infinite solutions. Well, that's true. There are infinite solutions because they have an infinite amount of points that they have in common. But it's not all solutions. Like, for instance, this point right here is not a solution, or this point over here is not a solution. It's only ones here. So how do we write that? Well, the way we write that is this. We are going to use some set notation. We're going to say all values of x, y, so all coordinates x, y, such that, and then you're going to just use one of your equations, because essentially since both these equations are the same, okay, you can just write one or the other, and there you go. And so this means all points x, y such that it would make this equation true. So any point, okay, that makes this true is my solution. Okay, it's not just any point on the graph, it's only the points that make this equation, or I guess you could have picked this one, but makes this equation true. Okay, and that's how you indicate that there are an infinite amount of points, okay, that make both those equations true. Okay, hopefully that makes sense, and that's how you graph systems of equations.